Welcome to Metrology lecture series. In the present video, we will discuss the example problem on a gauges design. Let's see the problem. Design the general type of go and not go gauges as per the present British system for a 40 mm shaft and hole. Pair is designated as 40 H8 D9 and given the information is I equal to the 0.45 into cube root of D plus 0.001 into D and basic size 40 mm lies in the diameter range of 30 to 50 mm and IT8 equal to 25I, IT9 equal to 40I and given the upper deviation of the shaft equal to minus 16 into D to the power 0.44. Moreover, it is given the wear allowance assumed to be 10% of the gauge tolerance. Let's see the solution. So here it is the given that one the basic size. So basic size is the 40 mm. So let's consider basic size is the 40 mm and this is the zero line or maybe the basic size. So next we have to observe the shaft and hole pair is designated as 40 H8 D9. So here 40 is the basic size and letters are indicated for the deviation and numbers are indicated for the tolerance grade. Here letters are the capital H and the small d and we know that capital letters for the hole and small letters for the shaft. So for the hole deviation is the H type deviation. We know that when for the H type of the hole lower deviation is 0, which means lower limit of the hole is equal to the basic size. So we have to represent this H type of the hole on the basic size. So this is the H type of the hole. Here lower limit of the hole which is equal to the basic size, and let's consider this is the tolerance and this is the upper limit of the hole. So next here it is given the D is the deviation of the shaft. So here D type of the deviation is given for the shaft. We know that for the D type of the shaft upper deviation is below the basic size. So for the schematically it is the D type of the shaft. So which is the its upper limit is below the basic size and this is the fundamental deviation. So the difference between the basic size and the upper limit of the shaft is calling as the fundamental deviation, and in the data it is given the fundamental deviation is the minus 16 into D to the power 0.44 and this is the tolerance. So next we have to observe the numbers. Here it is given the H8. So which means tolerance grade for the hole is the IT8 and tolerance grade for the shaft is the IT9. So this is the IT8 for the hole and similarly it is the IT9 for the shaft. So next we have to determine the geometrical mean of step diameter. In the data it is given the basic size is the 40 mm and this 40 mm is lies in the diameter range of the 30 to 50 mm. So we have to determine this geometrical mean of these step diameters, which mean capital D equal to the D minimum into D max. So in the step range 30 is the D minimum, 50 is the D max. So capital D equal to it's a geometrical mean between the 30 and 50. So capital D equal to the root of 30 into 50 which is equal to the 38.7298 mm. So next we have to calculate the value I and also determine the tolerance grade. We know the formula I equal to 0.45 cube root of D plus 0.001 into capital D. Moreover, I have to remember this I value is always in the microns. So then you have to substitute capital D equal to the 38.7298 in the I equation. Then we will get the I value is the 1.571 microns. Then you have to convert these microns into mm, which is equal to the 0.001571 mm. So small I equal to 0.001571 mm. So next we have to determine the tolerance of the hole as well as the tolerance of the shaft. In the data it is given for the tolerance of the hole is, so hole is the H8. So tolerance grade for the 8, that is the IT8 equal to 25 into small I. So I value is the 0.001571. Then 25I will become the 0.039725 mm. And similarly it is given in the data tolerance of the shaft is, so D9. So tolerance grade is the IT9. So tolerance of the shaft equal to the IT9 equal to 40I. Then substitute I value. Then tolerance of the shaft will become the 0.06284 mm. So third step is calculate the fundamental deviation and determine the limits of the hole as well as the shaft. So we know that so here given the H type of the hole. So for the H type of the hole, fundamental deviation is 0, which means lower limit of the shaft is basic size, that is the 40 mm. Then for the D type of the shaft, fundamental deviation is given in the data, that is fundamental deviation which is upper deviation of the shaft equal to minus 16 into D to the power 0.44. Here D is the 38.7298. Then this fundamental deviation value will become the, so 79 minus 79.957 microns. Then it is converted into the mm. It is the nearly, so minus 0.08 mm. So it is the fundamental deviation for the D type of the shaft. Upper deviation is the fundamental deviation. So from the schematic I have to observe, so tolerance grade for the hole is the IT8, and this IT8 value also we know, and also we know this lower limit of the hole also we know. So lower limit of the hole equal to the basic size, that is the 40 mm, and upper limit of the hole will become this basic size plus tolerance value, that is the IT8 equal to 25 I value. Then upper limit of the hole equal to the basic size plus tolerance. So the tolerance is the IT8 equal to 25 I. This value we determined. Then IT8 value is the 0.039275. Then upper limit of the hole will become the 40 plus 0.039275. Upper limit of the hole will become the, so nearly it is the 40.039 mm. So next we have to go for the shaft. So this is the basic size and this is the fundamental deviation, and this is the upper limit of the shaft and this is the lower limit of the shaft. Then upper limit of the shaft will become the basic size minus fundamental deviation. So that is so upper limit of the shaft will become the basic size minus fundamental deviation, which is equal to the basic size is the 40 mm and fundamental deviation is the nearly, this value is 0.08. So don't put minus of minus 0.08. So minus is indicating the below the zero line. So upper limit of the shaft will become the basic size minus fundamental deviation, which is equal to the 40 minus 0.08. The value is the 39.92 mm. Then lower limit of the shaft will become the basic size minus fundamental deviation minus tolerance grade. So lower limit of the shaft equal to the basic size minus fundamental deviation minus tolerance value. So basic size is the 40 mm, fundamental deviation is the 0.08 and tolerance on the shaft IT9 value is the 0.063. Then substitute all these value, then lower limit of the shaft will become 40 minus 0.08 minus 0.063. Then lower limit of the shaft will become the 39.857 mm. We determine the limits of the hole as well as the shaft. So next we have to look for the gauges design. So first we have to design the plug gauges for the hole. So we know that plug gauges, it is having the two plug gauges. One is the go plug gauge and second one is the no go plug gauge. And each plug gauge is having the lower limit as well as the upper limit. So this is the schematic representation of the go plug gauge and the no go plug gauge. So and here lower limit of the hole is the 40 mm and upper limit of the hole is the 40.039 mm. So first we have to go for the go gauges. So from the schematic we have to observe. So this is the schematic. Schematically it is the go gauge. So go gauge having the lower limit as well as the upper limit. Then lower limit of the go gauge equal to the lower limit of the hole plus, so this is the wear allowance plus wear allowance which is equal to the lower limit of the go gauge. Similarly this is the upper limit of the go gauge. So this is the wear allowance and this is the gauge tolerance. Then upper limit of the go gauge equal to the lower limit of the hole plus, so this is the wear allowance. So wear allowance plus this is the gauge tolerance. Then here from the schematic you have to say that lower limit equal to the lower limit of the hole plus wear allowance. Similarly upper limit of the go gauge equal to the lower limit of the hole plus wear allowance plus gauge tolerance. Similarly by observing this schematically we can be written the relationship between the limits of the hole and the limits of the no-go plug gauges. So here it is the lower limit of the no-go plug gauge and this is the upper limit of the no-go plug gauge. So from this schematically you have to say that one the lower limit of the no-go gauge equal to the upper limit of the hole and upper limit of the no-go gauge equal to the lower limit of the hole plus gauge tolerance. So here, so lower limit of the no-go gauge equal to the upper limit of the hole and upper limit of the no-go gauge equal to the upper limit of the hole plus gauge tolerance. So next we have to determine the gauge tolerances. So in general gauge tolerance is considering the 10% of the tolerance. So here we are determining the plug gauges and the plug gauges generally used for the hole. Then gauge tolerance equal to the 10% of the tolerance on hole. So we already determined tolerance on the hole is the 0.039. Then gauge tolerance equal to the 10% of 0.039 which is equal to the 0.0039 mm. So next we have to determine the wear allowance. In the data it is given the wear allowance is the 10% of the gauge tolerance which is equal to wear allowance equal to 10% of gauge tolerance which is equal to the 10% of the 0.0039 mm. Then wear allowance equal to the 0.00039 mm. So we know the gauge tolerance and wear allowance, lower limit of the hole and upper limit of the hole. Then we will go for the determination of the limits of go gauges as well as the no go gauges. So first we have to determine the limits of the go gauges. First we have to go for the lower limit. So lower limit of the go gauge equal to the lower limit of the hole plus wear allowance. So lower limit of the hole is the 40 mm and wear allowance is the 0.00039. Then lower limit of the go gauge equal to the 40.00039 mm. Similarly, upper limit of the go gauge equal to the lower limit of the hole plus wear allowance plus gauge tolerance, which is equal to the upper limit of the go gauge equal to the lower limit of the hole, so 40 mm, and wear allowance which is equal to the 0.00 and 039. Gauge tolerance is the 0.0039. Then upper limit of the go gauge equal to the 40.00429 mm. So next we have to calculate the limits of the no-go gauges. First I have to look for the lower limit of the no-go gauge. So lower limit of the no-go gauge equal to the upper limit of the hole, which is equal to the 40.039 mm. Then upper limit of the no-go gauge equal to the upper limit of the hole, that is 40.039 plus gauge tolerance is the 0.0039. Then upper limit of the no-go gauge equal to the 40.0429 mm. Next we determine the limits of the snap gauges. So here we are having the two types of the snap gauges, that is the go snap gauge, another one is the no-go snap gauge. So go as well as the no-go snap gauges also having the upper limit and lower limit. So this is the schematic representation of the limits of the shaft as well as limits of the go snap gauge as well as the no go snap gauge. So here, this is the go snap gauge and this is upper limit of the go snap gauge and this is lower limit of the go snap gauge. And here also this is the upper limit of the no go snap gauge and this is lower limit of the no go snap gauge. And this is the lower limit of the shaft is 39.857 mm and upper limit of the shaft is 39.92 mm. So then we can find out the relationship between the limits of the shaft as well as the limits of the go as well as no go snap gauges. So first I have to find out the relationship between the go snap gauges limits as well as limits of the shaft. So from the schematically we can observe that one. So upper limit of the go snap gauge, which is equal to the upper limit of the shaft minus this is the wear allowance. So minus wear allowance, which is equal to the upper limit of the go snap gauge. So upper limit of the go snap gauge equal to the upper limit of the shaft minus wear allowance. And this is the lower limit of the go snap gauge. So this we can written as the upper limit of the shaft minus wear allowance and this is the gauge tolerance. So minus gauge tolerance. So lower limit of the go snap gauge equal to the upper limit of the shaft minus wear allowance minus gauge tolerance. Similarly, next we can find the relationship between the no-go gauges limits as well as the limits of the shaft. So first we have to look for the upper limit of the no-go snap gauge, which is equal to the, so this is the upper limit of the no-go snap gauge, which is equal to the lower limit of the shaft. So upper limit of the no-go gauge equal to the lower limit of the shaft, and this is the gauge tolerance, and this is the lower limit of the no-go snap gauges. Then lower limit of the snap gauges equal to the lower limit of the shaft minus gauge tolerance. So next we have to determine the gauge tolerance as well as the wear allowance. So in general, gauge tolerance equal to the 10% of the tolerance. So here we are going to find out the gauge tolerance for the snap gauges. So snap gauges for using for the shaft. So gauge tolerance equal to the 10% of tolerance on the shaft. Tolerance on the shaft equal to the 0.063. Then gauge tolerance equal to the 10% of 0.063, which is equal to the 0.0063 mm. And wear allowance is the 10% of the gauge tolerance which is given in the data. Then wear allowance equal to the 10% of 0.0063, which is equal to the 0.00063 mm. So we know the gauge tolerance, wear allowance, as well as we know the upper limit and lower limit of the shaft. Then we can find out the limits of the go gauges as well as no go gauges. So first we have to go for the go gauges of the snap gauges. Then here upper limit equal to the upper limit of the shaft 39.92 minus wear allowance is the 0.00063. Then upper limit of the go snap gauge equal to 39.91937. Similarly, lower limit of the go snap gauge equal to the upper limit of the shaft minus wear allowance minus gauge tolerance. Then substitute all these values, then we will get the lower limit of the go snap gauge equal to 39.91307 mm. So next one is the no go gauges. First I have to go for the upper limit. So upper limit of the no go snap gauge equal to the lower limit of the shaft, which is equal to 39.857 mm. And upper limit of the no go snap gauge equal to the lower limit of the shaft minus gauge tolerance, that is the 39.857 minus 0.0063. Then upper limit of the no go snap gauge equal to 39.8507 mm. So these are all the procedure for the determination of the limits of the gauges. Thank you.